make a good camshaft in about 15 minutes.
You gotta really care about what you're doing.
So Kenny's been here for 46 years.
Oh my God, they got a Suburban in here.
Yeah.
How did you know we were coming?
There was some crazy stuff that went on with it.
It's Memphis.
Yeah.
That's all I gotta say.
We are standing in the warehouse at Comp Cams right now, and we're about to learn everything there is to learn about camshafts.
Billy Godbold and Lake Speed. Camshafts are really neat. You know, you start looking at it and people think that cam designers design lobes. They don't. They design the valve motion. So when we design a cam, we're designing valve motion. But when you design the valve motion, you figure out, okay, this is what I want the valve to do. Here's the rocker. You back it through the system. It's through something called, you know, my background is physics. You call it a coordinate transformation. Back to how the lifter needs to move. And that creates this cam surface profile that you need to grind. Well, you've got to grind it on something. So what we do, instead of starting with a bar of steel, what we'll do is we'll start out with a bar of steel that's already got the lobe spaced out, the gear made, the journals ground, the front work done, end work done, and all it's left to do is grind the finished lobes on it. So when you look at a camcorder like this, you know, it has the front work done, the rear work done, the journals turned, everything's made on this, but the camshaft lobes aren't ground. So this will be a cam core. I believe that's for a 4-cylinder Echo Boost. If you look at this, this is for a Ford modular, 4.6 or 5.4.
Those are not fun to change.
No, sort of like Michelangelo carving David out of the marble. You know, what do you say? He looked at the big stone of marble and he cut away everything that wasn't David. You know, he didn't add anything to it. Same thing here. We want to start with the bar of steel and cut away everything that's not your finished camshaft.
There you go.
And we're gonna find out how that happens right here.
Yep. When we talked about going from starting with a bar of steel and cutting away everything that isn't camshaft, the camcorder you saw actually was already through heat treat. Get an idea of what's happened before that is, you can imagine a big bar like this, stuck in this Akuma LT300. And so when you slide the bar in, you start out with the front, you do the front work, then you come in, pull it out a little bit, do all the spacing work, pull out more, do more spacing work, then you finish up with the rear. After it goes through all of that, we have what we call a spool. So this is a camshaft with the barrel done, all the linear set, but still the lobes are round. So a round lobe core or spool. From this point, the next thing happens, it goes over to the Mori mill over here, and they go in and mill the lobes up. After the lobes are milled to size, for the rough size, then it goes off to heat treat. So if it's an 8620 core, it'll be copper plated, then go to heat treat. If it's tool steel, it doesn't have to be plated. It just goes straight to heat treat. They go and quench and temper it. They bring it up to transition temperature, do a quick quench, and then do a triple temper to bring it down to the hardness range you're shooting for.
This is cool.
Yeah.
What era is this machine from?
These were made back in the 1950s. So this would have been a Berto cam grinder. It's got a degree head that sets your angles on here. So the camshaft fits in between centers, sitting on the steady rest here. There's an index plate on the back that sets it up for each angle. So you see this pin right here. You can grab that pin and change to each angle in the firing order. So as they go to each lobe, they'll run to the position on this. On the end here, you've got a spot for two masters. So the master is this plate that goes right on here. So you have an intake and exhaust master. And they go on this, and there's a follow wheel that's the same size as the grinding wheel. So there's a 17-inch follow wheel riding on here. The grinding wheel's back here. It's dressed with this diamond set up right here. This traverses across to set the wheel. And then the operator will go through there, put the machine in gear. And so the original cam that Lake had in 2002, it was ground on one of these machines.
Since there was nobody using these machines at Comp right now, here's some footage from the Holman Moody shop where Larry Wallace is grinding a cam that I got a couple weeks ago. You can kind of see how the machine works and how he turns that knob to bring the wheel in ever so slowly. I mean, it's really like, this is it. This is how it works. And this is how those CNC machines work on the other side of the shop, but you can't see inside there because of all the coolant spraying around. So now you know what it looks like. It's pretty wild looking.
So to do it, it really requires having really good Burco master. You know, if you don't have a good master, if you have a great master, this machine can make an awesome camshaft. The only negative of this machine is it can only make about 6 to 8 good camshafts a day. You know, because it's not terribly fast. You can see all the coolant is just coming out of this little spigot right here. There we go. So, not a whole lot without flooding the guy on the opposite side of it. When you look at the CNCs, you got a lot more coolant, you got a lot more horsepower, you got a lot really neat pretty piece.
So does those set your low profiles come from these?
Yes. So like I told you about the low profile, you start the valve motion and you get back through the valve train to the low profile. As you get that low profile, then you have to go, well, can I grind that with this grinder? If you can, you just make the master to do it. If you can't, you have to change your design to make it work. But this is another transformation. So this isn't exactly like the low. This is what profile is needed to make this table rock in order to produce that cam load. And it's funny, you know, when I started in 95, we had these little yellow lights on here. The guy would pull the string for the yellow light and say they needed a new master. And over on the side board here, there was a piece of pegboard, 2 4x4 squares that had all our masters. You know, now if you look, there's those offices over there. All of those offices in that corner are filled up with masters. There's about 12,000 of them now.
Wow.
So, you know,
say wow all the time, but
profiles.
Wow.
But you can see, at one time we had 16 of these manual machines. They're great, but they require, the only issue with these machines, they require making this master first. And it has, the camshaft can never be better than you make this master. The other problem with it is as you're running it, the person who's running this cam grinder is turning these dials to set the infeed. Having a guy standing here on his feet for 8 hours a day and turning this and never going faster or slower, doing it the exact same every time, gets really, really boring. And so very few people had the patience to learn to do this right, and then the patience to do it right every time. So that kind of moved us into a different era. Starting in the early 2000s, we started to get these grinders over here. Let me run you over here and look at the next generation. It's always fun to look at the shop because all these troughs in the bottom, that's coolant coming out of the machine.
Really?
These big 6-inch pipes, there's 1,000 gallons per minute of coolant going through these pipes at 80 psi. So if one of these pipes breaks, it'll look like a flood.
Has that happened before?
No, those are all Schedule 80. So, yeah, I was a little chicken that put 2 pipes in here. So these are the machines that are the next generation. So if you go over here and look at this setup, so instead of all the handles on it, everything's controlled with numerical control. The grinding wheel, instead of being a conventional piece, now is a CBM piece. This grinder will run 50 gallons per minute of coolant through it. So instead of watching it take material off, now all you see is like Niagara Falls. You know, with 50 gallons per minute, you can almost water ski out of what's coming out of it.
Yeah, you can't even see anything going on in there.
No, it's kind of odd to see what's going on. But what's neat is if you can go over here and put your ear to it, you can actually, you put your ear to it, you actually hear the material coming off of it. As it goes around, you hear kind of,
yeah.
So it winds up where you're actually watching it. Here you can see like this grinding wheel is going 3,000, 160 RPM, and it also shows you how well balanced it is too. So we can measure things on this and do things. You know, that machine we could never have put 50 gallons per minute, you know, coolant to it. We never could have gone 3,000 RPM. We couldn't have controlled things as well.
So what's the turnaround time? How many cams can one of these make in a day?
This will make a good camshaft in about 15 minutes. It's a little more than a minute a load. So let's say 20 minutes.
That's
so
insane.
instead of 6 or 8 a day, we're going, 3 an hour.
Wow.
So it's amazing. The other thing you do is, if you see my friend Kenny over here, so Kenny and I have known each other forever. Kenny's actually the first employee that CompCam's ever hired. So when RHS decided they were going to grind camshafts and everything, and they were going to form CompCams, you start looking at it and go, well, what do we need to hire? Well, we probably ought to hire somebody who can grind cams. So before Comp, you were at Cam Dynamics, and so you've been here for 46 years. You did that without taking any shoes off or anything. So Kenny's been here for 46 years. Now, when we were grinding everything on those manual machines, like Kenny did every Pro Stock cam for Bob Glidden, Steve Schmidt, Grumpy Jenkins, all of the guys through that whole series. Also, all the NASCAR cams for all the Childress, all the Ralph, all the Yates, all the DI. Now, when you realize we talked about doing this by hand, how you have to move that end feet so smoothly. One night about 2 in the morning, we were doing some camshafts for kart racing, not like go-kart, like the CART,
like IndyCar
type stuff. Yeah, wow. And it was like 2 in the morning. I don't think we can say who we were doing it for, but like 2 a.m. and he took a 10th off of the lobe all the way around. I was in there checking with the ag holes. But the nice thing about having the CNCs is you can take somebody who could run those Burcos and then have him come over here and work with somebody like me and make these machines do with numerical control what he was doing with his hands over there. And with the same tricks like sticking your ear up to it and listening to it, hands on it, feeling it, these machines will talk to you if you'll listen right.
Interesting. Can you beat the machine?
No. But I can come close. But the machine couldn't beat him.
Back in the day when I was running a Burco out there, I was real close to doing that. My numbers wasn't out into the 10th where we are now.
Wow.
Well, it's close.
That's cool.
So today you still have the same guys who are running our Burco machines. They moved over to the CNCs, they're training a new generation, and they're able to take what they were able to do on that old world Craftsman style and put it into new world, some of the best grinding technology available.
So he's taking them out of here and putting them in these bins. Where do these go? When he's got this whole thing full, what happens to him?
So what you'll look at is you'll see these big carts. These are kind of a staging carts. You'll see these smaller carts running around here. So as soon as they grab that cam core off the shelf in there, so a salesman puts in the order, it creates a serial number, and it creates an order in our system. They go and look and see what core number was on that system. They pull that core number, they go over to the laser marker, and they mark that core. As soon as that core is marked, so this core has been pulled off the shelf, it's been marked on the back. As soon as it's marked, it goes over to the guys, Billy Kaiser over here will do cam straightening. So they'll straighten this camshaft, make sure the cam core is straight before it goes in the grinder. The guys in engineering create all the files for the programs for it. They put those on the network. Kenny will go over here then. Billy will bring these camshafts once they're straightened over here in the cart for Kenny. Kenny will get the camshaft. He'll pull up all the information in one of these computers between each of the machines that tells it what the program is. They'll get that program, they'll put it on a jump drive, they'll take it over to the CNC control, they'll load that program into the Kuma. Then he'll load this setup, he'll dry wheel it in, make sure it lines up, get all his angles right, then he'll close the door and push go. And then 20 minutes later he opens it up and hopefully it comes out like that one.
So is he managing multiple machines?
Yes, that's a neat thing. One of the things is like you're trying to find out how do you get 4 Kenny Arundels or how do you get 8 Kenny Arundels? Well, one, we haven't figured out cloning yet, and two, it's probably not ethical. But instead of cloning Kenny, which Kenny wasn't all good with, we thought about chopping him up and putting parts everywhere. We took part of his finger off and then, you know,
Try to grow it
tried to grow it out. It didn't work well. I've been flipped off with that finger several times. But instead of cloning Kenny, what we can do is have Kenny set up, load this machine, run it, set up, load this machine, run it. So one operator can run about 3 machines. So with these 8 grinders that are in this cell, about 3 operators and a runner can keep this thing going pretty much, you know, constantly. We just brought 2 new Landis machines. Now, these machines, the Akumas use a ball screw. The Landis runs a linear drive on it, and it's got a smaller wheel. Instead of 350 millimeter, it has 250 millimeters. This can run, instead of 3,000 RPM, this winding wheel can go about 5,000 RPM. So this machine can grind 2 camshafts at the same time that machine can grind 1 to the same accuracy.
Smaller too.
Yeah, it's a smaller piece. Pretty neat little, it's a smaller, faster, neat little piece. Thing is those machines were about $500,000 each. These are about 1.2 million each. But really, if you think about the time, this one will grind more cams per $1 million spent than that one will per year. So, you know, the problem with this one is it's a little slower on setup. So it's better for high volume. That's better for your one-off pieces.
Okay.
And if you slow the machines down over here, you know, this running at about a cam in about 20 minutes, this running a cam in about 8 minutes is roughly the same quality. So they're very, very close.
Interesting.
And you'd think going slower would be better, but honestly it's not, because as you run this camshaft, the faster you can turn this camshaft around while it's grinding, the more you can get coolant in there. So being able to spin the camshaft faster and have the wheel stay with it actually grinds a little bit better camshaft than turning slower and taking less off.
Does the heat input?
Right. It just has, you're putting the same amount of heat, but you're getting that coolant back. You're putting heat into this region for less time before you move to the next region. So you really want to grind a cam as fast as you can, not as slow as you can.
What do the old school machines get used for now?
Really, they're used for, like, a lot of times we'll have tractor cams and things like that. Say something will come up that we're used to grind at Crane that we don't have the design data for, but we have the masters. We use them basically for the really oddball stuff. Tractors, you know, nailhead Buicks, you know, anything that you just really don't have the ability to run on one of the CNCs. For the most part, it's less expensive and makes a better part to grind it on a CNC. That's why we don't have 16 Burcos anymore.
This is the fun stuff right here.
You know, this probably is my favorite room. My two favorite rooms in comp cams would be the test cells we have in the back and our quality room. And when I first started at comp in 1995, I wanted CNC grinders, and I wanted them so bad I could taste them. I tried everything in the world to get my boss, Scooter Brothers, to buy a couple of CNC grinders. And it really wasn't going well. And so what happened is eventually he just took me aside and he said, Billy, you want to make ball bearings, you want to measure them with the wood calipers. And he said something that was probably one of the most influential things I've ever been told. He said, Billy, you can't make something better than you can measure it. And that led to basically this room in here. In 1998, he and I flew to Marlboro, Massachusetts to meet with the Addison Coal Corporation. And we sat down and talked to them about what they have been just making is the state-of-the-art rotary CMMs for camshafts. And you can see our first one over here. So we bought this unit in 1998. So this camshaft was measured on it. You can see it has the degree head down here. It's got two Heidenhain diffraction grating encoders on it, on about a 12-inch head. This can measure an angle down way, not to the millionths, but not even to the trillionths, but actually further than that into a degree. I actually calculated one time, it's a wavelength of light on 12 inches times 2 because you have opposite encoders on it. You have the same Heidenhain encoders on the probe that goes out and measures the camshaft. So we had these before we had the CNC grinders, and it works very much the same way. You know, when the cam comes into QC after it's been ground, the operator goes in here and he puts in the information about camshafts, types in the serial number, and it will tell them everything about the camshaft. Then they take that and they go over to the AGCOL and they input what's the core number and what's the sequence. When they start the routine, they ask it what's the intake design ID, what's the exhaust ID, what's the lobe separation advance. It then creates a temporary part data file and it measures the camshaft three cuts of lobe to 1/4 or 1/10 of a degree depending on the machine. So either 1440 points or 3600 points on all 3 cuts on every lobe. And it compares that to actually the design. So whatever Chris Potter, Chris Zaleski, or I design, it will check this lobe every 1/4 degree, 3 places of lobe, every lobe.
How many times did you come in here yelling at somebody that they didn't grind it right?
I mean, honestly, with something like this, the problem is when engineering has so much to do with the programming, when the CNC ground, there's almost none of that, because you can imagine that what happens is, if this turns out bad, I probably did something bad in engineering, because the grinder is going to follow that profile. So honestly, it's almost the other way around. When something comes up, when red ink starts coming out of that printer, these guys call up our department of engineering and say, what did you guys do wrong? Because of everybody who's liable to make a mistake, Kenny making a mistake is once every 5 years. Chris Zaleski making a mistake is once every year to 2. Me making a mistake was like once every 45 minutes or so. Yeah. So, you know, most of the mistakes would be traced back to me.
Well, what's really cool about this machine is when we were doing oil development, this was how you could see what the oil was doing. So what we would do is take camshafts that you would design and grind here. We would AGCOL all 16 lobes first. Then we put them in the engine. We would run this durability test, very precise, speed, load, time, sequence. Take the cam back out, fly it back here, check all 16 lobes again so you could see exactly how much wear was occurring on the camshaft.
And when he says exactly how much, you have to understand that these encoders are diffraction grating encoders, so they measure to a wavelength of light. So, you know, to measure, you know, 0.0000001 inch of wear is really, really easy as one of these machines. And because you're taking 1440 points in 3 places, you've got this tremendous data set. So you're going to see anything that has come off. So that's how you can, you know, when we say, hey, Lake, I think this one wore 2 millions. I'm saying, hey, Lake, I really think it wore between 1.9 and 2.1 millions, not, you know, 1 or 3. You know?
Right.
So it's really a neat thing.
It was amazing because you could do repeat tests too, right? So if you saw a result with, say, one formulation, you're like, wow, that was amazing. Well, let's repeat it. Let's go back and run that same test again with a new camshaft, and let's go back and see. And with that level of accuracy, it was amazing. And we did that for years. We learned all kinds of little things, like, you know, a roller cam like this will never have any kind of phosphate coating on them. We saw a bunch of them out there that had the black coating on it. Well, that's a phosphate for break-in. Well, the roughness on that would throw this measurement off. So we were doing flat tappets with no phosphate. So we could get even more accurate, more repeatable.
Right, when you're looking at the oil, the phosphates kind of throws you off because that phosphate coating
is helping the oil.
Is meant to add an additive to the oil.
Right.
So it softens the very, very top edge, makes it a little bit rougher, but adds this lubricity additive to it. So.
Yeah.
Are we gonna throw this one on there?
It starts at the bottom of the camshaft and works its way up because there's a little bit of slack that you can get in the ball screw if it started at the top and moved down. So it's a lot more accurate using gravity to hold the drive head down as it moves up. Okay.
So this is the big brother version of the little handheld profilometer that I'm always carrying around checking cylinder bores with.
Yeah.
So the handheld one is called a skidded profilometer. So it's got a stylus like this, but you notice it doesn't hang out long like this. So this one doesn't drag across the surface with a little skid. This is a skidless one where that needlepoint tip will drag across it. And this can give you waviness and other things that you can't see with a skidded profilometer. So while mine's like $2,500, this is like $75,000. A little more accurate.
Yeah, this can repeat down to 2 micro inches. And to give you an idea, you know, how small 2 micro inches is, like the exhaust smoke is 80 micro inches. E. coli is 40 micro inches. Red blood cell is 280 micro inches. So when you look at this bottom part, from minus 100, plus 100 to minus 100 micro inches, this whole scale is actually, you know, a red blood cell would fall outside of it. So this is the first line is raw data, and this has all the tapers. So then we take the taper out and look at the crown. This shows the crown of the lobe when we grind it with a slight crown. Then the third plot is showing the flattening that out and looking at what the surface looks like.
Super amazing cool. Between this and the ad call, you can know for a fact what's happening on that camshaft.
Right.
So if you're trying to measure for wear, we were with oil, this combination is unreal good.
Through all these engine videos, we have learned a lot about engines. A lot of that revolves around oil and the importance of oil, what it does, how it works, and what's in the oil, how oil is constructed. If you're a fan of the channel, you know that we really like Pennzoil Platinum. There's something really cool about that. Now you see where it says made from natural gas? You probably wonder, what the heck does that actually mean? Now that's a full synthetic oil, and what that means is conventional oil takes crude oil, and it's a really long chain of molecules that, quite honestly, are a bunch of things that you don't want in your engine. So they have to refine that to get as much of that gunk out of there as they can. Basically taking like dirty creek water and filtering it. You can't get everything all the time. And a motor oil is only as good as its base, because the base is what the additives go in. The additives are the things that keep your engine happy. It's like building a house. If your foundation is no good, you don't have a good house. And what the natural gas does is they are able to take that molecule, refine it down to the purest base possible, and then they build what they want on top of that, so the finished product is much more pure. Like building a house from scratch with a great foundation where you didn't cut any corners, versus tearing a house down to a foundation that has been around for a long time and then building something on top of it. It doesn't come out as good. Next time you check the odometer and it's time for an oil change and you go to the parts store, give Pennzoil a try. You won't regret it.
So you can kind of see this little edge up here is slightly higher. Then you come look at the lobe and you can see where the reel was running, there's a little more wear on the high side of that lobe.
Yeah.
And you can even see if you look closer.
Science is so cool. That's why Billy's great.
But if you look at this even closer, take a look at here. See all these sharp points over here?
Yeah.
This is outside of the wear area where all these sharp points, and then you can see where the lifter actually has worn the camshaft. So when it was ground, it wasn't a 13 RA, it was probably a 20 RA. But then at the time, our spec was 12 to 24 RA. So it probably came out here about 20 RA, and then as it wore, as it ran, it took all the high spots out and actually became better. And it's still, like you can see the high spot where there's more wear, everything, it did exactly what it should do. So when you grind the camshaft, like when you looked at that, you could see there was all these little mountain range on there. No matter how good, whether you grind to a 20 RA finish or 10 RA or 5 RA, you're still gonna have like mountaintops. Now, what super finishing does is it's not like having a road grader that goes through there and shapes it. It's more like having a finishing mower out on Fenway. You know, you go in there and you just take that little rough grass and you trim it off to be all one nice smooth finish. So this guy, really, we can't help it a ton, but Jackson, you want to run it and see what it looks like? All right. This will make a nice trophy out of it. So we got a nice little soupy mixture of burnishing compound, and if we go through here and run it at about 10 to 20 G's, 200 pounds of media in there becomes all of a sudden 2,000 pounds of force equally across the surface of the camshaft, and it will go in there and basically just mow the grass. It won't fix anything in there that's messy. You know, if you have a bad cam, it just makes it look worse. But if you have a good cam, it can take a good cam and make it really, really good. So this might look worse after it's done.
No,
It's gonna look pretty? Okay. How does it take you about?
y'all got 10 minutes to kick it around.
I guess you just have to sit around and wait. Is that what you do all day?
Nah, actually I have 2 of them running, so I'm running both at the same time. Once this one stop, and I'm back and forth, so I'm always moving. I just don't have anything now to keep it really just going. So that's why I was over there.
What do you do over there?
I'm polishing cans on the belt polisher over here that doesn't get MSC processed.
Yeah, the steady rest will leave a little line on the journal. So Jackson will come over here and make sure that, see this real small line here?
Yeah.
This is that carbide foot on the steady rest on that Akuma grinder. So you send it out looking like this, people get mad. Jackson's job is to make people not mad.
Yep. Good quality cans.
Yep. And so he does a great job with this. The other thing that he does is, like I said, when the cam runs to the MSC, if there's any fault in the grinding, like the dress was bad or anything like that, when he takes it out, he's going to look at it really good, and he'll be able to tell. The light will catch it differently, and you'll be able to see things visually that you can almost can't pick out with anything other than the profilometer. So he's really the last step for quality before they go to get packaged.
Is it cool knowing that your eye is more valuable than an expensive machine?
Yeah. it's really something. I mean, you gotta really care about what you're doing. If you didn't care, you wouldn't catch it.
That's what's awesome about it.
That's cool.
And what this machine basically doing is like we did the plateau hone to make the surface smoother on top to have more load bearing area to those valleys to hold oil on the hone. This is basically plateau honing that cam finish to make it have more load bearing area.
That's right. That's a good way to think about it.
Yeah, when, you know, the thing is when every time that serial number is done, like we know, like if Kenny Arundel ground it, we know who ground it, we know who picked the core, who straightened it, who ground it, who checked it in QC, and then Jackson will put his name on it. So, you know, when you think about it, buying a camshaft from Comp Cam, you're getting a signature camshaft because everybody through here that touched the cam put their name on the report to say that it was going through the system. It's a pretty neat deal.
That is neat. If you haven't seen those other videos yet leading up to this with Blake's dad's engine, he was talking about honing the block. We did that at Greg Anderson's shop.
Yeah,
it's all on the Racing History Nerd Zone playlist, along with a bunch of other stuff you'd probably enjoy watching.
It's super cool to geek out on, I can tell you that.
Look at this door handle.
Yep, piece of camshaft that's been polished and nitrided.
Did you design that door handle?
No, actually Nick Blank did the door handle.
Oh, this is a cool spot. Oh my God, they got a Suburban in here.
Yeah.
How did you know we were coming?
The Suburban is actually the perfect test vehicle. You can put 6 engineers and like 20 bags of concrete in the back of it, go out on the interstate, floor it, and probably not get a ticket for the next 5 or 10 minutes.
Unless we built it.
So this is the toy store at Comp Cams. This is where all our engines are for testing. Everything for Edelbrock and Comp comes through here. See the Godzilla with the sheet metal intake on it. Different Spintron blocks for an LS. Probably an old top fuel block over there to do some top fuel development. Everything that you want in here. So throughout this test deal, we have different cars for doing our in-vehicle testing. Have a chassis dyno, airflow bench, Spintron, first Spintron cell, second Spintron cell, first dyno cell, second dyno cell. You need big chassis dynos over here. So lifts for putting things in. Every product that we do at Comp, everything that we do comes through here and we qualify it here. We make sure that we have tested something and run it as hard as you are before it goes out, before you put it in your engine. So you can see nice soundproof cells in here. A normal Spintron setup will have a hole in the block over here, so you can put a laser in there and measure the valve motion. We'll have the ability to run strain gauges on valve springs. We can run a load cell under the valve spring. We run strain gauges on the rock arm, run strain gauges on the push rod. You know, laser tracking of the valve. There's an encoder in there that measures every degree, so we get 1 degree resolution coming out. You know, just basically It's everything that would go on an engine, except instead of having a piston with combustions, there's just a dummy crank, and electric motor drives the system.
The downside is the dummy crank doesn't have any crank throws on it. So if you try to break in a flat tappet cam on that, guess what doesn't happen? There's no oil splash. So you kill your camshaft. So we had to work on that, and we came up with some interesting ways of making sure we got enough oil so we could actually test things on the Spintron. Because otherwise, roller cam is fine. It doesn't need as much oil, but that flat tappet has got to have the splash.
Got to have some splash.
Which is one reason why it's so important to actually, when you're doing a flat tappet break-in, is to not let the engine idle. Is to get it up to 2,500, 3,000 RPM and let it stay up there. Is because you need that splash from the crankcase to make sure you're getting enough oil where it's supposed to be, when it's supposed to be there.
Makes a lot of sense.
Yeah.
They don't really explain that. They just say you have to do this or it's bad.
Yeah, it is bad, and we learned the hard way why it's bad.
Right.
Who gets to go out and test the cams in the cars? Do you want to do that?
No, no, that's not me.
You still work here, Billy?
No.
The Comp Cams was recently purchased by the Edelbrock Group, and they are in the process of moving that whole facility over to their new mega compound in Olive Branch, Mississippi, down the road from where the original place in Memphis where they're at right now. And we're about to go into the old offices, which are now empty and kind of, you know, eerie looking. It's pretty cool. You guys will never get to see this again, and it probably won't be too long from now that this entire factory is all moved over to that new facility. The real deal meat of Competition Cams facility will be forever memorialized in this video, and we think that's pretty cool. It'll move on, they'll be doing better, but there's one spot. They've been there since like the late 80s, I think, so there's a lot of history in this video that will be fun to look back on in years to come. So let's check out that old office. Billy's got some funny stories. Are the walls carpet for sound?
Yeah, that was the whole idea. Now it actually works good for padding too, because one time I got picked up by a salesman and thrown into the wall, and it's much better to have carpeted walls, not only for sound deadening, but it cushions the blow when you get tossed into the...
Where did that happen?
I think there's a dent still. It's in this room over here.
These are the questions we're here for.
No, it was...
They make cams somewhere on a different wall, but we want to see where Billy put a dent in the wall.
Yeah, right between these two doors. So there's my dent somewhere between that door and that door. I don't think there's a stain still, but you know, Tim Langley picked me up and threw me into the wall right there. Because this was Chris Brown's office, where Buggy's office is now.
What year did this start being the office?
You know, this would have been the office starting probably in about 1990. You know, I didn't get hired until 94. So my first day here was like January 5th, 1995.
Does it look the same?
You know, the posts are still carpeted. The floors are a little different. The walls were carpeted then. The cubicles were a different color. They weren't, you know, this is an upgraded cubicle from what we first had.
These are like circa 2010, 12, I think.
Yeah, I think, yeah, but they were used. There was a guy who sold used furniture that Ron really liked. So we never got new furniture. It's just when someone else's business, you know, upgraded, we got the hand-me-downs. Yeah. But, you know, that didn't make a nice cubicle didn't make a better camshaft.
No,
you know, so
exactly.
we put it all in the equipment in the back. Yeah, you can really get thrown into this. It doesn't hurt that bad.
Do you shampoo the carpet? Do you have to shampoo the wall too?
No, but
Clean
it's funny
carpet,
that
Well, I guess that's
that
valid.
a feral cat got in here one time, and it would run straight up the wall, hit the
Tile.
fake ceiling, and it'd flip up and then go running across. So it knew which ones were soft. So there was some crazy stuff that went on with it.
It's Memphis.
Yeah.
That's all I gotta say.
You holding a camshaft like a bat in a door. It's Memphis. If you are thirsty for more camshaft information, you're going to be happy about what's coming up, because we got a couple more videos. One of them with Billy, the guy we were walking around with, where he explains how cam lobes work, how the different designs do different things, and most importantly to everybody, how you can look at that lobe design on a piece of paper, a graph, and he shows you how different attributes will affect the sound at idle. Wow. I know you're gonna love that. I was fascinated. So make sure you're subscribed to see that. And if you like factory stuff, we've done a handful of those too. So like Blueprint Factory for crate engines, heck, even a Newell Factory, how they make motorhomes. Just like seeing factories, how they make things, machinery, processes, is cool. You learn something every time. And if you'd like to support the channel, you can check out StapletonAutoworks.com and see if any of the shirts or hats we have are something that you would like to have. Like the one I'm wearing right now. This is a PFI shirt though, because we like Brent, but yeah, not a very good salesman. I guess I should be wearing something of ours, but you gotta wear your friend's stuff too, so that's what I'm doing. And the Escalade's up on jack stands right now because it just pulled the transmission out to get it refreshed. Isn't that right, Shelby? Yeah. Yeah, screw up the camera. Good job. Good puppy. Yep. You can find a video pulling the transmission and stuff on the Stapleton 42 Extra channel. That's where we're going to put things that we do in here that maybe aren't necessarily interesting enough to put on the main channel. Like, pretty sure you guys have watched me take this transmission out before, but if you wanted to see me do it this time as opposed to like 3 years ago, you can find that over there. So we're glad you're here. And for you diehards who are still here and haven't checked out yet, I say this every time, we do this for you. I am talking to you. You are why we are able to do this. It's not the people who watch for 5 minutes and click away. It's you guys. So thank you.